This note set is to give you a few examples of how we do age dating of rocks, and I guess more importantly for you, how you're going to see these things on the exam. So, for instance, here's our first example. A simple example. I have a given rock. I'm giving you a rock, and I can tell you that I've measured it, and there is 25% of the parent remaining. Now this first question I ask, how many half-lives does this represent? This one isn't calculating anything. It is simply asking you to understand the graphs. So, what's the answer? The answer is 2 half-lives. How did you get this? So, if I say it has 25% parent remaining, I look over here on the y-axis, I find 25%, then you shoot over horizontally, straight over to the solid line decay curve, and you go straight down, and the answer is 2. So 2 half-lives. Here's a second example. Now this one's going to involve some calculation. Here's that same rock. It has 25% parent remaining. I know that I've chosen an isotope that has a half-life of 250 million years. And so, boom, how old is this rock? This is a thing that is asked of geologists all the time. Do the same thing. Now notice here, I'm going to always give you 2 numbers, and you have to calculate a third number. So, 25% parent, you find it on the y-axis. There it is. You shoot over to the decay line and straight down, and there's the 2. So, what does that mean? How do you answer that? How old is the rock? Well, that's 2 half-lives, 2 HL, times that 250 million years, MY. 2 times 250 equals 500. So that rock is 500 million years old. So, on a test, a multiple choice question, I would show you this diagram, you'd have it, I'd ask you something like that, and I'd say, how old is the rock? And the choices A, B, C, and D would be some set of numbers, different numbers, so you have to do the simple math here. Now students ask, can I use a calculator? Well, I don't care. And obviously, if you're doing it online, I can't really watch you to see it. If you're doing it in class, no, you don't need it. I've deliberately picked numbers that are easily divisible or multipliable that end in 2 or 0 or 5. So things that you should know that you've had as your known math facts since elementary school, they'll serve you well here. There's a third type of example that lends itself easily to questions. What if I give you a rock and I tell you that the rock is a certain age? This rock is 1 billion years old. And the percentage parent remaining is 25%. I could then ask you, well, what's the half-life? See, that's different. For the previous question, I gave you the number of half-lives and the percentage parent. I gave you the half-life itself and the percentage parent. Here, I'm asking you what is the half-life. So how do you solve this one? So again, you go to the percentage parent axis, 25%. Shoot over to the line, go straight down, it's 2 half-lives. So we know this fact, 25% of the parent equals 2 half-lives. So, and I know that the rock is 1 billion years old. So in other words, it says that this chunk of time that I'm moving here between the cursor is 1 billion years old. So 1 billion years old divided by 2 is equal to, well, 500 million or 500 million. Simple problems like this are what you should expect on the test. And not even too many of them. Just a couple to make sure you understand what's going on.